All right, testing, 1, 2, 3. Okay, cool. Looks like we're working on both YouTube and Twitch. Nice. Okay. I'm figuring this dual streaming stuff out. Cool. All right. Let's see. Let me get a couple things open. Okay, first off, got my camera. What's up? So I'll use this anytime I have something, I don't know. I have a bunch of monologue to give you guys or something. I don't know, whatever. But I intend on keeping it off most of the time, so. All right, let's get into it. Oh yeah, I'm also gonna show you, I got my Linux reversing VM set up as well, so I can jump back and forth between Windows and Linux. Um, this is just a Kali Linux setup, just because I'm lazy. But I'll show you what I needed this for here in a bit, specifically to decompile some LUAC files. So I'll show you guys that in a little bit. But let's see where we left off. We were kind of digging into the file system on this device. We had SSH access. We were digging into the file system, looking at the software that's running on that, what kind of tools are running. We got Nginx that is handling most of the HTTP traffic that goes to the device. And then it also has some CGI bins on top of that for the LUA scripts, like the GL-iNet specific LUA scripts. So some things that I dug into off stream was the actual API calls that were being done with the RPC endpoint. So this whole device, I guess let me go ahead and show you. Just open this up. 192.168.8. All right, so I'll show you real quick the API calls that I was messing with. When we go and log into the device, we'll see a bunch of requests being made out to this RPC endpoint, all sorts of requests, and they all look pretty generic until you look at the actual request and you can see some JSON that's being sent back and forth. And one of the things that I was messing with were the login, basically the authentication flow, trying to figure out how I can actually do that with my own code outside of the browser. I got somewhat close, but it's being a little picky. So I basically steal the token from a session, and then I can do anything that I want authenticated through the API itself. But these RPC calls, these all get sent to the Nginx backend, where it has a LUA-based CGI bin that talks to the ubus infrastructure, the OpenWRT ubus system, to perform some authentication. And let me get PuTTY open, and I can show you a little bit about that on the actual device. All right, so the let me get this open up over here. So I went and I ran a couple find scripts. Where are we? This one over here, I ran this find command, looking for anything with GL splat across the whole file system. So I'm looking for anything that contains like GL-iNet. Just looking for the GL-iNet specific vendor files. So this kind of came up with a bunch of interesting things. Also came up with a bunch of nonsense in here, bunch of noise. But some of the interesting things are down here. Let's see. This stuff under user share, some interesting stuff. We've got the GL-NGX. which is the LUA setup for the CGI bin. And then let's see. I should have taken some notes. That way it would have been a little bit more fluid, but whatever. It's a live stream. If you guys have any questions, just throw them out into the chat, and I'll try to answer them. Also, if you want to see something in particular, like if you want to see me dig into a particular aspect about the device or something, just say something and we can look into it. So let's see. So let me go to let's see, user share, or no, is that lib? No, sorry, user lib lua gl folder. All right. Oops, oh, permission denied. Okay, so actually it's not this one. Where is it? Var? No, it's not var. All right, let me just find it real quick. User local lib. I think that's what it is. User local lib. No. Ah, here we go. No. Oh, it's under OUI. I'm so dumb. Okay. So the main interface, the actual UI that you interface that you interact with in the web browser, this right here is the GL or I'm sorry, called OUI. There's a particular, let me see if I have it open. Yeah, here we go. Believe this is what they're utilizing. Go to this GitHub. So this is what they're using. Uses it's a tool to develop, your user interface or a UI. So I believe they utilize this to create the actual UI framework and everything that we see in the actual admin panel. So all of this is generated with a tool similar to this, and that's why you see references to OUI throughout here. So this file, let's see, I could just do a search across the system. So OUI RPC, let's see, find, my name, OUI RPC, do splat. User share, okay. GL-NGX. There we go. Okay. Yeah, so this and I can show you with the actual NGX config. There we go. Okay. So if we open up the Nginx config, we can see that the RPC endpoint is served by this file, the OUI RPC LUA. And then we've also got our upload endpoint and our download endpoint that are also being served by these other LUA files. That's what's actually listed over here. Now I've gone ahead and I've pulled those off the file system just so that I can inspect them with some syntax highlighting and other stuff. So this one right here is the main OUI RPC endpoint. This is what gets handled by this Nginx config. So right here, user share glx OUI RPC LUA. So any RPC request that you make, or any request that you make to this RPC endpoint through your browser, any of these requests that are going to this RPC endpoint, they come into the system. and they hit Nginx redirects them to this OUI RPC LUA as a CGI bin file, and that's a I believe common gateway interface, something another. It's basically it's old school APIs effectively. It's before we started calling them APIs. We called them CGIs. So inside of this LUA file, and I've been doing a little bit of reading and research on this LUA file. I'm not super versed in Lua scripting, but I know enough coding to kind of read some files and figure out what the hell they're doing. So in this case, let's walk through the some of these requests. We'll go ahead and I'll show you guys. I'll walk you through the authentication flow so we can break out how this actual API endpoint works, because it's kind of interesting, and it's pretty decently secured. I'm sure there are some flaws, like all security or all software has flaws, we just don't know it yet. But after plenty of hours digging through this, I didn't really find anything real obviously wrong with it. But to start off, what we see in our browser when we do our login, the first request that it does is it makes a post HTTP request to this RPC endpoint. And if we go ahead and we look at the headers, we can see we've got some pretty generic headers. Content type is application JSON. We're accepting JSON, text, plain, all that other good stuff. Our user agent's pretty standard because we're in a browser. Our cookie, we have an admin token cookie right here that doesn't seem to have anything in it. And you'll see how that actually gets utilized later. But if we look at the request, the actual request body, it's composed of JSON. We've got an ID field, a JSON RPC 2.0 field. Our method, our RPC method, is challenge, and then we've got a parameters dictionary right here with a username parameter of root. And if we look at the raw, you can see that's just straight up raw JSON. So it makes this request, and then the server responds with a similar JSON body. The dictionary that it provides is contains a salt, an alg, and a knots field. And then I'm expecting, or I'm guessing, the browser does some stuff in its own JavaScript. So we have the browser, I'm sorry, the web application itself is this JavaScript file running in the browser. And I'll dig into that a little bit later to show you how I basically reassembled some of this authentication logic by kind of reversing that this JavaScript file. So this request, we send it out with our username root, and it responds back with a salt, an algorithm, and a knots. And then the next request that our browser makes is it sends another RPC request with the method login, and then this time it's got a hash, and it's also got a username. The server itself responds with result username root, and then it gives us an SID, which is like a randomly generated looking string. And then we'll go to the request after that, and we'll see that our browser is requesting this RPC endpoint again, and this time it is using the method call, and it's sending an array with 4 values in it, 0, 1, 2, 3, and the first one looks like our SID value from the previous request, and then we've got a UI and then a get menu list. So these 3 requests kind of demonstrate the authentication flow as done by your browser. So when you log into this JS file initiates these requests to the RPC endpoint. The first one goes to the challenge method, provides a username. It gets back a salt, an algorithm, and a knots. And then your browser sends back a hash. Presumably it did some funny stuff with that information that the server sent it, and then resulting in this hash. So then it sends this hash back to the server, and then the server responds with, okay, good, here's your username and your SID. And SID, I'm guessing, is session ID. So let's go ahead and take a look at the the CGI bin that is responsible for talking to these requests, or responding to these requests, so to say. So this is the OUI RPC LUA file that the CGI that Nginx serves for this CGI bin. And if we look up at the top, we can kind of walk through how this works. The first thing it does is it checks to see if the request method is not a post. If it's not a post, then we respond with HTTP forbidden. So this endpoint only wants post requests. Then the next thing it does is it reads the body of the request, puts that into a data variable. We can see where that data variable gets used all throughout this code. So then what it does is it checks to see if that data value or that data variable actually has some data in it. If it doesn't, then it goes through and it gets the body file. This, I'm not too sure what the deal is with this. I haven't actually seen the browser utilize this at all. This little bit of code. I have kind of poked at it a little bit, and it looks like if you don't send any data with the request, it'll go and try to process a file. So I'm not too sure what the deal is with that. I'll need to dig into that a little bit more to figure that out. But as we continue along, we can see a bunch of functions defined. We've got RPC method challenge, we've got RPC method login. Let's see, we've got RPC method logout. RPC method alive, these sound like methods that are exposed to the CGI bin. That the browser can actually request or talk to as if they're endpoints or RPC methods. So when we scroll down a little bit more, we get to this little list right here where it's got a dictionary of methods, and they're all referencing the actual function calls themselves. So we've got a challenge one that goes to our challenge function, a login that goes to method login, and so on and so forth. So if we scroll down a little bit more, we can see that actually gets called right here. So methods, JSON data.method, JSON data.id, JSON data.params. So what it's doing is it's calling the individual methods based off of what is sent in the JSON data. So this is where it processes that JSON data. So it goes through and it parses that JSON. It looks to see if it can decode it, checks to see if the data types are tables, strings, and whatnot. If they don't match up, it responds with these error codes. If everything is fine, then it calls the method based off of that JSON that you pass to the endpoint, and that's this JSON over here. So this is our method. So you can see method challenge. So let's go ahead and follow through that flow. So let's find our challenge method, which is this one right here. So our JSON data method would be challenge, JSON data ID, JSON data params, or nothing. So let's go and scroll up. We'll look at our challenge method. So our challenge method is right here. And let's follow through what does this actually do. So the first thing that it does is it gets sets a result variable to the output of ubus.call, and then that ubus.call function is getting passed GL session, challenge, and then the params that are passed to that endpoint. So in this case, our params are username root, so that's what would be passed to this function. So we've got username. Imagine username root lives inside this this params value. So we're passing that over to ubus call, and it's a dictionary. So let's go ahead and look into our ubus file and see if we can determine how that ubus call is working. Does anybody have any questions? If anybody has any questions, just throw them into the chat, and try to address those. Let's see, where is that file? I guess I didn't pull it. I think I've got it on. We could just go look at it right here. where was it? It was user share GL NGX? No, just find it. Do, do, do. There we are. This one right here. So cap that out. Actually, let's just do less. All right. So what this ubus function does when we do ubus.call, we pass it an object, method, and then a dictionary of arguments. And then what that's going to do is it's going to call ubus.connect, and it's going to pass all that crap that we sent to the ubus connect. And then if it errors out, and then it returns the response there or returns the response. So it's a pretty simple function, just calls ubus. There's a whole LUA, OpenWRT LUA setup. Let's see if we can pull that up. All right. I'll enable JavaScript. All right, so, and we'll get into ubus a little bit more on the command line here now, in a little bit. This is the inter-process communication setup that that is utilized by this device for various processes to send data back and forth and communicate with each other. Kind of like an MQTT server, if you're familiar with that, where you have kind of like a pub sub sort of setup, which is publish and subscribe. So we looked at this in the first stream. I printed out some of this stuff from ubus. I've got the actual ubus verbose output. So if you run ubus v list on a host that actually has ubus running, it'll spit out all of the objects and methods that are associated with those objects. So these are our objects. We've got a container object, we've got DHCP, DNS mask, file, GL clients, GL session. This one should seem familiar. And then we've got a bunch of various methods that are associated with those objects. So for instance, for a GL session, we've got our challenge method, login method, clear session, status, logout, blah, 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 blah. And the way this works is software, like our LUA script or our CGI bin, can go and call ubus and pass it these objects and methods along with parameters, and then perform functions and all sorts of fun computery things with that that infrastructure, that setup. And it allows kind of like a kind of asynchronous sharing of resources, so that you're not having software step on toes and stuff and having to share links to the same files and the same memory addresses and all kinds of crap like that that gets real complicated when you're dealing with a huge system or a setup that's complicated, kind of like how a router would be, because there's a lot of moving parts when you consider that you have your let's just take, for example, our admin panel. It seems pretty simple or pretty straightforward at first glance. It's just a web interface to, change settings on the device and everything, like set the wireless power or whatever. But when you really stop and think, like, what does it do when you click on max and you change it from max to high to medium to low? How is it actually doing that on the back end? There's some software somewhere on this system that is taking that value from your web interface, and it is sending that somewhere else to a config file that changes the actual power limit on your wireless chip. So there's a whole lot of interconnected stuff going on behind the scenes. And at first, it seems like all of this stuff is pretty simple. You just have a web interface to do it. But what does that actually mean? There's more to it than that. Having a web interface isn't just a little bit of HTML and then now you can talk to the SD card that's plugged into your device or the USB flash drive that's plugged into your device. There's a little bit more to it than that. And that's kind of why I do this stuff, is because it's fun to dig into these systems and figure out how they actually work and how all of this stuff is interconnected. We use these tools. Oh, I guess this is a perfect opportunity for the camera, right? Because I'm doing a monologue. Yeah, so we use these tools on a daily basis, like our phones and routers and just all sorts of smart appliances we use on a daily basis, and we don't actually understand what goes on under the hood, and what makes them tick. How does this stuff work when you connect to a device on your phone, a smart IoT device on your phone? What is it actually doing? You're telling the device from your phone to do something. How does the device actually know what to do? How is it getting that communication from your phone, and how is all of this stuff connected? And I think that's pretty interesting, and I think that's kind of what I want to share, is that you can do this. You can go out to the store and buy a piece of hardware and take it apart and plug stuff into it and figure out how it works. And you learn a lot of things, and you might actually find some vulnerabilities or find some ways to do something better or make your own stuff. So it's pretty interesting. I think is kind of the whole monologue point. Anyway, enough of that. So we've got our RPC methods. We've got all of these are in here. As we mentioned, our ubus just makes a call to these. Our RPC methods just make a call to ubus, which then in turn runs some functionality, or some code. But where does that code actually live is the question. So let's go ahead and see if we can find out where that code lives. I already found it. There's a file called GL-NGX session, and this is the LUA CGI bin that the Nginx is Nginx or Nginx. I don't know. I call it Nginx, whatever. But this is the CGI bin that Nginx or that ubus talks to. Sorry, I actually that's wrong. Let me rephrase that. It's not a CGI bin. This is the LUA file that is behind that ubus object and method. So when we go and we look at the ubus and we see this right here, GL session, this is the code that lives behind that. So whenever ubus is talked to, that information gets sent to this code. I wish I could tell you how I remember or how I figured that out. I think I was just doing some searches. I think it was the GL splat. Came up with this user sbin GL-NGX, and I kind of opened that up, plugged into that, and saw that it was related to these session functions. So let me dig through this a little bit. And this one's pretty interesting because it actually contains the logic for the authentication. What happens on the back end on the ubus side of things, and how it will make your session, keep track of that session, and then provide that to the RPC CGI bin. All right, and let's see. So this script is also another LUA script. Up at the top, we have this nice little block comment, which is very helpful. This is what it looks like is a block comment, an LUA block comment that contains a bash script. So I imagine this bash script, if you were to run this, you'd be able to authenticate to ubus locally on the host itself. And so I'm guessing that the ubus, this GL-NGX session code does effectively what this bash script is doing. I'm sorry, let me rephrase that. This bash script is testing. It's doing what this ubus code is supposed to handle. Because if we scroll through this, we can see that there's some mentions of ubus call GL session challenge, and then we've got it's doing some stuff with the algorithm and the salt and the nonce, and then we've also got some stuff where we're generating an encrypted or an encoded password with OpenSSL using the crypt algorithm. And then we're taking that and we're creating a hash out of it. And then we call ubus again with GL session login. So if you were paying attention earlier, this would probably strike you as familiar with the actual, oh, I don't have it anymore, but the actual login flow. If you noticed in the login flow, those requests that our browser was making was very similar to this flow where it calls session challenge and then it calls session login. And it does a bunch of stuff with like an algorithm and a salt and a nonce. So we're kind of getting a little closer to the actual logic behind those requests. So what the server is sending to the browser, which is cool. So let's dig into this a little bit more, and maybe we can figure out how that's validating the data that the browser is sending the server, and then how it's determining what to send back. So up at the top of this file, we've got some imports, some requires where it's requiring some libraries and helpers and stuff. And then we've got some variables being defined, like our max session, some login values and stuff. Then we've also got some dictionaries for retaining some values like our nonces and session. And then we start a U loop. So I'm guessing this is for ubus. This will kind of like be a constant listen and send loop for ubus to do stuff with. And then we've got some kind of helper functions up at the top. We've got our clean GL token function, our init function, our time now, get crypt info, create nonce, our login test, create session, and then down here we've got a call to ubus add, and then this goes through and it adds the actual methods, the code and logic for handling the ubus methods themselves. So you can see this is our object, our GL session object. This corresponds directly with ubus right here. So we've got GL session, and then you'll see we'll find all of these methods: challenge, login, clear, session, status, logout, session, touch, blah 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 blah. We'll find all that here in this this file shortly. So we've got our status function, that's our status method, challenge method, login method, our logout method, our touch method, session method, and clear session method. And then we call init. So you can see these are all of the, this is all the code that's responsible for the ubus backend. So that's kind of interesting. So anytime our browser sends a request, an RPC request, to the challenge or the login methods, those the values in those parameter fields get sent all the way to this code, and that's where this gets handled. And we can break that down and kind of dig into how that's working. And we'll start with the challenge method for that. All right. So the challenge method, when you call this challenge method with ubus call, it's expecting a request and a message parameter. And you can see from that message parameter, we pull out a username. And this username is used throughout this function for various different things. The first thing that we do with it, or that the code does with it, is it checks the type, checks to see if it's not a string. If it's not a string, then we reply back with invalid parameters. And then we do some login timing count stuff. We'll check the login wait value minus the login now. And if it's greater than 0, then we send an error saying, hey, you've timed out your logins. And I believe that's for like a failed to login timeout. So if you spam this login and you fail a bunch of times, it's going to time out and make you wait. So, which is kind of nice to see. And then we'll see that we get an algorithm and a salt variable assigned by this get crypt info. We can go up there and dig into that here in a minute. But what we can assume is that alg and salt are the algorithm and the salt used for encrypting that password. So if we don't have an algorithm, if that value is empty, then we set our login fail. We increase it. We increment that by 1. And then after a login fail equals the max count, then we set that back to 0 and we set the wait time. And that's where we'll run into this little bit of code if we try to authenticate again. And then we reply with our error code access. And then what we'll do is we'll make a nonce. So if there's if we successfully get the algorithm back, we'll make a nonce. Call this create nonce function. We'll pass the username, and then that'll make a nonce for us. If we didn't get a nonce, if the nonce failed to make or failed to create, then we send an error code access error. So if everything checks out and make it down to this little bit of the code, what we're going to do is we're going to reply with basically what you saw in that JSON. We've got our code and we've got our data, which contains the nonce, the algorithm, and the salt. And so that'll get passed back to the browser, at which point your browser is going to do some funny stuff with that, turn it into a hash, and then send that back to the server. All right, so and that's kind of the end of that challenge function. Let's go ahead and take a look at these two functions that we're not familiar with yet, which is the get crypt info and the create nonce. So get crypt info, this one is defined up here. You pass it a username. If there's no username or the username doesn't match a format, then we return nil and then we end the function. And then what it's going to do is if our username does match this string pattern, which is basically just any characters, what it'll do is it'll open up the shadow file. And if you're unfamiliar, the shadow file on a Linux system contains contains all the users on the system along with their encrypted passwords, encrypted and salted passwords, hopefully encrypted and salted. Depending on how old the system is or how insecure it is, sometimes those passwords can be plain text, which is really awful. Sometimes they can be just MD5 hashed, which is also really awful. But newer versions of Linux and more secure systems, what they'll do is they'll use more secure methods like bcrypt and PBKDF algorithms. And in this case, I believe we're just kind of using the old crypt algorithm, but it's salted, which is good. Which means that there's a unique string that's provided during the password encryption process that if you don't have that salt or that that unique string, then the results are going to be all gobbledygook and they won't match up, and your encryption isn't going to work. So it's kind of a way to provide a unique value to encryption. That way, say we have the same password, say you and I have the same password, and we go and we send it to the server. What it'll do is on the back end, it'll generate a salt and it'll encrypt that password with that salt and then store the salt alongside the hash. And then that way, when you go and you do your validation, you want to check that the password is the same. Later, when the user logs in again, you can take that salt and you can take what the user provided you. You can do the hashing algorithm again with that salt, and you should result in the same password. What the salt prevents is it prevents users with the same password from having the same hash, which makes it easy for, say, when a password database gets breached or dumped or something like that, you've got all the hashes for all these passwords. If John and Sally have the same password and they're not salted, you'll be able to see immediately that they're the same password because they have the same hash. But if you salt them, those hashes are going to look completely different, even though the password underneath or that was used to generate that hash is the same. So it's an extra layer of security, and I'm sure some encryption nerds out there will be happy to correct me and provide additional details where I failed. So I'm not the smartest at really any of this stuff, but that's kind of the whole point in doing this is to learn more and just to educate yourself. But back to where we were. So the shadow file contains your password, your encrypted password, along with the salt, along with the username and the algorithm that was used. So our LUA file is going to go through, our LUA code is going to go through, parse that shadow file, pull out the algorithm and the salt for the line that matches your username, And then if we have an algorithm, we return that along with the salt. So that's all get crypt info is doing, is it's going through and it's actually pulling the all right. I guess the stream broke, as it is wont to do. I'm not sure where I got cut off at, but sorry about that. Got my coffee. All right. So, let's see, where was I? So, let me get this out of the way so it's not actually covering up the screen. Okie dokie. So let me just make sure this is going on YouTube. Okay, cool. It looks like it's still working. So what I've got open right now is Bruno. Bruno is an API testing tool for sending HTTP requests. You can send all sorts of get, post, put, blah, 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 all the HTTP requests. And then you can do some automation, which is pretty nice. Set up some scripts, some automatic variables, and some environment variables in order to automate your testing, which is really useful for what we're trying to do. Because if you've noticed, the browser, what it does is it does kind of like a sequence. It's not just send one request and you're authenticated and you're good to go. Excuse me. There's a little bit of a sequence to it. Where there's like a step by step. First, you got to hit the challenge endpoint, then you got to, do some weird stuff with that nonce that it sends you, and then you send back a hash to the login endpoint. At which point the server, if everything is a-okay, it'll be like, okay, cool, and send you back your SID. So there's being able to make some scripts is very useful in your testing, and this just kind of facilitates that. Makes it a little bit easier than having like a huge ass Python file with a bunch of crap going on in it. Which you could do. You could just have a Python file that just makes these web requests, or PowerShell or Bash or whatever the hell you want. But having something like this just makes it a little bit more visual and also a little bit easier to keep things organized and manipulate stuff. And yeah, so it's a cool tool. But I was messing around with it to try out some of the challenges. in the login APIs or endpoints. So this is what I've got going on. Just basically how this tool works is over here on the left hand side. You can set up requests, like individual requests. You can have folders with stuff. You can see over here I've got 3 requests configured. One is a post to the challenge endpoint, one's a post to the login, and one is a post to the logout. When we open these up, we have a couple tabs over here. Got our request parameters, our body, headers, auth, vars, script, assert tests, and docs. And then we can also change the way it. We also change the data type that it is sent, that it is sending, and the way that it is viewed in the GUI. So for our body, what I've got is I've essentially copied what this is. So if we go and take the raw output of this, and we go and paste that into Bruno. Oops. Why are you like this? Why is the raw output base 64 encoded? What? I wonder if that is the reason why. Nah. Okay, never mind. But anyway, let's do a edit and resend. We'll come down here, grab all this crap out when it's not base 64'd. And we'll paste this in here just to give us our generic one. And we'll prettify that, make it a little bit easier to look at. So as you can see, we've got our basic, request. And if we set this up and we send it, it'll probably give us the right token or the right value. I've gone ahead and set up some scripts and stuff already to do some stuff like automatic values and variables. But let's just go ahead and run this, and we'll see what it gives us. All right, so here's the response from the server. You can see that it appreciated what we sent. It was all properly formatted and everything. Of course it was, because we copied it straight from the browser. So it appreciated that, and it replies back with a result with our salt, an algorithm, and our nonce. So that's identical to what it would reply. Go and we look over here, except we've got a nonce that's different, and the salt looks to be the same. So this nonce starts with QW2, ends with OMW. This one is HGET, ends with BGY. But if we look at the salt, XFP 4YK, those look to be the same, XFP 4YK. So it looks like the salt doesn't change, but it does look like the nonce changes, and the algorithm doesn't change as well. So that's interesting to know. The browser, what it does with this data, we have no idea. I mean, I know because I did a little research, but we're not too sure what it does with this. So it gets this data back, and then it does something, and it sends it back to the server as a hash. So how do we figure this out? How do we figure out what it's actually doing with this information? Unfortunately, this is where it gets a little ugly, mostly because JavaScript in a browser is very nasty. These little JavaScript files, you can see the actual stack trace for them is quite busy, and none of it is properly labeled because web developers are weird, and what they like to do is they like to compress their JavaScript. They like to take their JavaScript, make a whole bunch of it, and then compress it into like tiny, tiny little cubes or extremely long lines, and then ship that to your device in like 7 MB packets. So JavaScript in the browser is a little annoying to like troubleshoot or stack trace, I guess. But let's go ahead and we'll try it out, and I'll demonstrate like how far I had to do this in order to understand what's actually going on the back end with this data. So we'll go ahead and we will log in, and we'll see these requests. Actually, hold on, let's log out. We'll refresh this whole page. Sometimes it does this, I'm not too sure why, but it won't actually like log the data. And then, yeah, here we go. I'm gonna actually debug this. So let's refresh this page. And then we will turn on our debugger, our breakpoints, and we will log in. And you'll see it pauses at an execution step. And we can look at the call stack and the event listener. And you can see this gnarly ass huge fucking JavaScript string. And this is honestly arguably why I don't really like web development. But if we copy this all out and we paste it over here, look how awful this is. And this is just because JavaScript is like there are tools used to minify and compress this stuff into something that doesn't. I don't understand why they do it. Okay. There's no reason to have this. um, the idea is to compress it so that you don't have like huge function names and huge variable names all over the place that take up more data to send to the device. Instead, you just use the variable name t, and you use that everywhere, and it gets really confusing. So you have to, as a reverse engineer, you have to kind of work around these tools to compress and minify JavaScript and libraries and stuff to figure out what they're actually doing. So in this case, this is all of the JavaScript on the website that's being ran. You can see that they've got some nice comments in here that tell you like what the actual libraries that they're using are. But we need to find out where our hash is being manipulated. So let's go ahead and we'll continue this, and we'll what we're gonna do is we're gonna step through this execution and keep going until we get to the point to where we see something related to our password, right? All right, so keep stepping in, keep stepping in. I don't see anything in the wrapper or in the call stack yet that looks interesting or familiar. We'll keep going, we'll keep going. So nothing in here. Let's go ahead and step out of that one. And keep going, go a little bit. Nothing. Okay, step out of that one. And you could probably control F if you really wanted to. So I don't think this function is really doing much for us. Let's step over that one. Go into the execution a little bit on this one. Clear timeout. This all looks like it's stuff related to, yeah, handling your clicking the login button. So we're gonna step over this function. We don't want that one. We'll let that one keep going. All right, this is more handle clicks. All right, I'll get out of that one. All right, handle clicks. Keep going, keep going. Yeah, we don't want that one. Let's just keep stepping over functions until, see, I don't know, I was kind of just poking around at this, and then found it. Let's keep digging in. We'll see if anything shows up. Oh, there we go, handle login. All right, so I think we're getting closer to the actual actual code that's doing this. So we'll step into this function. All right. Yep. And then keep an eye over here as well on the actual like code JavaScript that's being ran, so you can see where at or what the function names that it's calling are, because those are going to be the unique identifiable things. Because when you see a lot of like return object h.call function f, You know, like function f doesn't mean anything, but when you reference f.crypt, that means a little bit more. So that's kind of what we're looking for. All right, let's step out of this one. We'll keep going. No, step out of that one. Step out of that one. Okay, now we're in handle login. All right, so login form validate. Let's see, challenge username. There we go. Okay, so this is where we're getting some interesting stuff. So challenge username, this form username. Then what it's doing is it's defining a constant, algorithm colon E, nonce colon R, salt colon N. So those look to be the variables for our response. So when the server responds back after we say we log in with root, it doesn't actually have a username field right here, which is kind of interesting. But on the back end, it's authenticating with root is the form username. And then it gets responded to by the server with this data, the algorithm, the nonce, and the salt, you remember? And then so what we see here is it's calling this .up.crypt. UP is makepass. So it's calling makepass, a constructor for makepass. So this is where it's actually doing the encryption. And what it's encrypting is this form password EN, and then it takes it and it runs it through MD5. Yeah, so this is the actual logic that the browser is doing, actual code that the browser is doing to encrypt the password. So let's go ahead and copy this out just so we don't lose it. All right, I don't think we need that much. Let's just get all the way over to here. And I already copied this out earlier, but we'll just do it again, just for shits and giggles. All right, language, let's see, JavaScript. Okay, cool. And then let's see, let's go ahead and try to break this up a little bit more. Just make it a little bit easier to read. All right, cool. All right, so what this is doing, this little bit of JavaScript is doing, is it's defining a constant that contains our algorithm, which is the variable E, nonce, which is the variable R, salt, which is the variable N, and then it's calling up crypt, and then let's see, there's a JavaScript library that corresponds with that. Can't remember what it's called. It's a user pass or something like that. Check 1 second. So node modules. Yeah, Unix pass, that's what it is. So there is a JavaScript library. npm Unix pass. All right, so this is the library that the browser is using to hash this password or encrypt this password. And it's using this specifically up Unix pass .crypt, and then you pass it your password, and then you give it a salt with an algorithm. So you can see the algorithm is specified here. $5 uses the SHA-256 algorithm. And then you can also check it. So that's what the browser is actually using. If we go back and look, it calls unixpass.crypt, and then it's got the password from the form, which is what the user typed in. And then you can see $E is going to be the algorithm, and then $N is going to be the nonce right there. So it's taking the nonce, or I'm sorry, not the nonce, the salt. I got confused. So you can see salt goes right here, and then we've got the algorithm right here, and then it encrypts that, right? So it encrypts that whole thing, stores it in the variable O, and then if we look at this next line, it does an MD5 hash of the username plus a colon. So let's go ahead and type this out. So let's say our username is root, and then got our password. Let's say our password is butts, right? So username is root, password is butts, and what we want to do is we want to encrypt this. So what we're going to do is we'll just encrypt it. We'll just say that this is the encrypted password, just as representation. Or I'll just do all zeros. That's our encrypted password. So what it's going to do is it's going to encrypt our password, which is the this right here, and it's going to encrypt it with the algorithm and the nonce. And then what we're going to do is we're going to take that and we're going to call MD5, and we're going to pass it a string that looks like this. It's going to be root, root colon O, which is our encrypted password, colon, and then R, which is our nonce right here. So our nonce is going to be something like, I know I grabbed one of those over here. So this is our nonce. All right, and then this method right here, that one's gonna, let's just pretend that one is up.crypt. That gets called with our password butts, and then the string right here, which is going to look like this: $1, and then our salt, because our alg is 1, and then our salt. So that's what's going to get passed to the actual crypt algorithm, or the crypt module. And then this value is going to spit out, we'll pretend that that's what it spits out. So there. So then this gets sent to MD5, and then that spits us out a hash that then gets sent to the server. So if we go back and we look at the actual session, we scroll up to the top, we can kind of see that this block comment with the bash script is kind of doing the same thing. So what it's doing is it's taking the it's making a password variable with OpenSSL to encrypt the raw password. You can see the raw password. It's pretending that's 1, just for verbosity's sake, I guess. So it's encrypting that with the same salt that's provided, the password in the same algorithm, and then it takes that and it sticks it right here in between these colons and the nonce and the username, and it pipes that to MD5 sum, and then that's what the browser is sending back, or yeah, what the browser is sending back to the server. So it's kind of the actual hashing, I guess, algorithm on the back end. So it'll take that, the browser will take that hash and then it'll pass it back to the server. The server then calls a GL session login with that. One of the things that I tried to do is emulate that whole flow with Bruno. So if we go and we look at the script section, we can see at the post response, when this request goes out and then it gets a response back from the server, it's going to run this code. It's going to run this JavaScript that I put together to manipulate these values. And you can see I'm calling the same library, the Unix pass crypt, right? Calling it with the salt and the algorithm. So just to walk you through this really quick, we import our libraries, Unix pass and crypto.js. And then we set a couple environment variables with Bruno. So bruno.set environment variable, we set our salt, our algorithm, and our nonce values. So when this reply comes back from the server, it's going to have the salt, algorithm, and nonce values in the response. So response body result, and then salt. So it's going to grab this value, and it's going to stick it in this environment variable, and then it's going to do the same thing for the others. And then after that, it goes and it defines some constants where it gets the values from the environment variable. And then it does some funny stuff. So it does the magic sauce with that. So you can see it takes our password variable, sticks it right here in our crypt, our call to the crypt method. And then it takes our salt and it sticks the algorithm onto the front. I've just statically defined it as 1 because it hasn't actually changed at all. And then it takes that value and it puts it into our environment variable as a hash. And then we take that hash and we run it through MD5 along with the other data that the server is expecting. So we take our username, colon, the hash that we generated, another colon, and then the nonce, and then we turn that into a hex string. We set that as our token. So if we go ahead and we look at the environment variables, we can see all of the magic that that has done so far. So we've got our salt, our nonce, our algorithm. The ID is being generated automatically. I haven't found that actually. Ah! Oh man, ship broke again, didn't it? That's annoying. Maybe dual streaming is not meant for me. Let me test this real quick. All right, there we go. We will just stick with YouTube for now. I think dual streaming is fucked up. I don't know the setup yet. I haven't messed with it enough. I'm trying to do it with my own software instead of using like Streamlabs or whatever, because obviously it costs money. You can do it for free, but clearly there's a reason why it costs money. Anyway, go back to this. I don't know where I left off, but we are trying to get the requests set up properly. So what this is doing is it is checking the, where is it? Let's go and look at util. Where is util? I thought it was under util. Guess not. Oh, okay, it's right here, salt and algorithm. So login test, this one on its pairs. So concat's a table. Username, password is, I'll match the whole, is it the whole thing? Or is it the username up to, geez. So it's gonna get the username, and then everything from here to here. So that's what's gonna be in the actual hash itself. Get environment variables password. And let's make sure we're actually using this Unix pass right. So let's go look at the actual code. Huh. Regardless, I think this is probably our Rosetta Stone right here. So it takes those values. Oh, is it putting another? It's putting another $sign at the end? Right there? Is that what that is? Okay, hold on. Why is it? No, that doesn't make sense. Maybe I just don't understand JavaScript string insertion. Let's check. JavaScript string insertion. So it's what is the $sign notation? What the fuck is that? I'm not very good at JavaScript, by the way. JavaScript $sign parentheses or $sign curly brackets. Template literals. Thank you, Stack Overflow, both multi-line strings and string interpolation. Okay, so it does look like it is actually sticking another. I don't know why it does that. So it crypts that, and then it sticks it in there. Let's check our session again. So this matches, and then it captures this part. So after that first colon, captures everything except colons up to the colon. So I've got that, this. Oh shit. Oh. Is that what it is? I'm missing that extra $sign after the salt? No. Oh. Okay, I think I'm getting there. Okay, let's just try this. Let's just try this. Plus another $sign. And we'll go look at the environment. 3v9d blah 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 166. Let's just make sure these hashes are the same. So starting here, we've got NSJ UHS hitting in WUO. Yep, yep. So those hashes are the same. That's all good. And then let's see what the browser got. That's not right. What the fuck? Okay. So request for root. There's our nonce. Let's copy that. Let's try this again. Set our nonce as that. Salt, get the salt from the environment. Oh, geez, that's, no, wait. Okay. Um, Interesting. Okay, so that looks like it's right. But maybe I'm not doing the MD5 properly. How is it? What library did it use for this? It's not MD5. Huh. All right. Maybe I need to get, can I spit out? Hash dot. But no, because it's just straight up taking the hash. It's not doing anything else with it. Maybe my MD5 isn't proper. I don't know. Do not know. Can't think. Oops. Nope, that's not what I want. Let's see, where was I at in this JavaScript? I think I'm gonna have to find it again. Unfortunate. All right, let's see if we can just do a control F through it. Let's see, this dot up dot correct. No, I don't think that's it. All right, whatever. Just go through this again. Let's see, is that what we're looking for? No. Maybe it is. Mm, nope, let's just do it again. Okay. Oops. All right, pause it. Do the login. Step out, keep going. Oop, did I just miss it? I think I just missed it. Okay. Let's just... Oh, incorrect username and password. Alright, let's try this again. This time, without the suck. Okay, cool. And a login. There we go. Alright, let's step into these. Press F11, we'll keep stepping into this, step into this, step into this. Keep going, keep going. Actually, step out of. Okay, I think this is where we were. Yeah, okay, cool. So what is I? What the fuck is that? What is I? See if we can take all this shit. Let's see, Cyber Chef. Cyber Chef, my beloved. Paste without formatting. Let's see. JavaScript. Beautify. Of course. Generic code beautify. Oh, Jesus Christ. This is why I hate JavaScript, man. This is so bad. I mean, JavaScript is cool and you don't use it like a crazy person. Let's see. Yeah, I don't know. I don't know what kind of MD5 it's using. Maybe that's maybe that's the problem. Crypto JS MD5. Da, 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 da. Hmm. Yeah, I don't know. I don't know what the deal is. Last time I tried this out, it was giving me very similar, if not the same hashes, but they weren't working. So maybe I was just reading them wrong. I don't know. Let me double check. So we have our salt, we have our algorithm, we have the knots that we're sticking in there manually. We have our salt, our knots, get the username from the variables, get the password from the variables. Oh, the password was the same. We already checked that. Let me take the salt. Then we take our username, all of that good stuff. Utils.md5. Where is that it? Is that in here? No, of course not. Does it always stick them? Hmm. Table.concat. Let's see. Table.concat. Okay, so it only sticks them in the center. Gotcha. Okay. Just wanted to confirm. I wanted to make sure that it wasn't sticking this colon at the very end as well, and it's only separating them. Yeah, that looks like it should be good. I don't understand why. He's not playing nice. It's got our knots, got our token. The password's still set, right? Username, hash, knots, two-string, crypto, encoding is hex. Let's see. Maybe it's using a different MD5 library. Um, I don't know, I guess that's the tricky part where you gotta figure out which library it was using to hash it. If it's doing the MD5 hash in like a very slightly different way, then it's gonna fuck us up. We're not gonna get what we need. Hmm. How do I figure out find in file require? Nope. About I equals. Yeah, Jesus Christ. Hmm. Can I just, D5 is not defined. D5? No. Yeah, that's not, I don't know what I'm doing. Okay, let's see if we can figure out what it is based off of, the file system. Let's check the JavaScript. Let's see. So gzip that out. This might be bad. Who knows? We'll see. Good God. All right, let's go ahead and we will try. Let's try it. Let's make a new one. So let's do new folder, call this one download, and we are going to make a new request. Request name, download, what is it? Post to HTTP 92.168.8.1/download. All right, and this will make a little bit more sense when we start digging into the download endpoint. I did this not long ago, but it's got to be a post. We need content type URL form and URL encoded. Let's see. Then we need our SID. Need path, blah, 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 blah. Okay, so let's go to body, make this, it's JSON. So once the headers, if not headers content type. So it just needs content type header. So let's get that. Add a header, content, oops, content type. What? That's so weird. Content type. I don't think it really cares. It just wants to see that it's there. Not header's content type. Okay. Oh, okay, so it wants that. There we go. So it wants that. And then let's see, get body data. Da, 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 da. So args, params is args data. All right, and then body. I believe I need. Let's just copy. Copy one of these. Stick it over here. I don't think we need all of this. We just need a path. Path. www. What is it? What is the path? JavaScript. And then what is the name of it? I want that. All right. JS. And then that. Okay, cool. So that's what I want. And then we need an SID. SID equals. And then we're just going to steal the one from the browser because that's how we roll. Do. All right, so we're going to steal this, copy that token. That's our SID. 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 Okay, cool. And let's send this. See what happens. 500 internal server error. Okay, so where are we running into that at? Just go to our download. See. Internal server error. I think we broke it. Let's go ahead and tail var log jinx error. Add argument number 1 to open. Oh, this might be fun. Okay, so it finds the path. Let's see, unauthorized not found, open path. Application contact that stream. Let's look at our request. No body found. I mean, no body. Bruh. Oh, is it because I'm dumb? Form URL encode path equals path. And then SID equals SID. Oh, wow, look at that. Okay, cool. All right, so this is I kind of messed with this a while ago, but this is how you download stuff from the host. Because I tried to use SCP, Secure Copy Protocol, and SCP doesn't work because there's no FTP server on the actual host on the device, so that doesn't work. So I had to find a way to get files off the device so that I can analyze them and inspect them a little bit further. And one of the ways I found out how to do that is to use the download endpoint. And one of the ways that you can take this apart, or at least figure out how the endpoint works, is inspecting the actual CGI bin, which is what we just did. We determined that it requires to be a post request. Also needs a content type header for URL form encoded, or form URL encoded. And then you also have to have an SID and a path parameter in your body. So we picked form URL encoded data. We put our path and our SID. And then we fulfilled the obligation of our content type header. Then we sent that to our download endpoint, and then as you can see, it spit all that back out for us. So this is our JavaScript that we want to. This actual application, the web app, everything that gets ran all comes from this JavaScript file, this minified, compressed, ugly JavaScript file. So we've got that now, which is cool. We can copy that out and save that. Let's go ahead and save that to Mingo. Let's see, new folder, JS. And we'll just do app.js. All right, cool. So we've got our application. And then let's go ahead and let's see if we can get this into here. Open file as input. Gonna go to our Mango folder, JavaScript, the app JavaScript. Let's see if it doesn't kill itself with this huge fucking file. All right, so I guess that's a little bit better. Let's try the JavaScript one. Since it's an actual full ass, oh no, okay. Okie dokie. That's okay. All right. We'll copy that out. I'm not quite sure this is going to help us a whole lot, but app .js. Got some CSS in here, whole bunch of crap. Let's see. Let's just do a search for MD5. Let's see if we can find that. MD5 with RSA, MD5. What was that? Unix pass MD5.js. Unix pass MD5. Well, that is the right one. All right, so Standard is that. Let's see. See if we figure out how this is working. It should just be fine. I don't understand why it's not accurate. Unix passcrypt MD5. Nah, see, they're using a different tool for that MD5 sum. I'm pretty sure. Different library. Because I don't think this library does like an MD5 sum. So they're doing that extra step at the very end. Let's see. It's all just a bunch of crap for. Let's see. Find all in current document. Let's just do this. Doing this the hard way. Or maybe not. Jeez. Okay. Okay. Alright, so does DS crypt, password salt? I like this, that's funny. Rounds are given explicitly. The salt becomes rounds equal number, where number is the first digit of the number of rounds. This is already so brain damaged that we'll just ignore it. Alright, well, we got that working, so that's cool. We can download anything from the host now. Well, mostly anything. Let's figure out why this isn't working. I'm very, very curious. So we send our challenge. That works. Let's go ahead and we'll check this again. Okay. Access denied. Let's see. Oh, there it is. That's what I want. Request hashes. CFB. Okay, so a response. This is our nonce. Let's go ahead and we'll try this again. Script nonce. Replace that. Right. All right, and then we come out here. We check. Token is 704612. I don't think that's right. 704612. All right, so then we come over here, look at the request. CFB. See, why is this different? All right, I'll go back to our notes. A UI upload. Hmm. Oh, that's the upload one. I don't want that. Or is it NGX session right here? So where it's concatenating the username, the password, and the nonce between those. And then the password is line match, username, colon, captures everything after the colon plus. Okay, let me just emulate this in regex. So we've got our cat etc shadow. Let's go ahead and do that. Get this. Come over here, delete that. All right, and regex, regular expressions. Okay, so we want to start at the beginning of the line. We want root is our username, colon. We want a capture group, right? So we want our capture group, and we want everything except for colons plus. Okay. And then we do everything except for colons plus. Then let's see, list our capture groups. List our matches with our capture groups. Okay, so this is the entire capture group all the way out to the 0. Yeah, okay, so that's what it's supposed to be doing. As we presumed. For nonce and pairs nonce's username do. Hmm. So create a session, database get ACL by username, utils generate an ID, session SID. Okay. Not sure where this is failing at. Let's see, crypto.js 55 some. Hmm. Oops. Oh, is it because I'm using the hex encoder? Let's see what that gives me. 704.612.208. I still think that's wrong. Yeah, CFBD, blah, 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 blah. What the fuck is the difference? Why is... Hmm. It is JHUS. Okay, so that's still right. Hmm. So that's 8L, 8L. Because I'm doing the salt differently. Configure, nope. Right, so it sets that as the hash. Let's see, configure that's the hash. Okay, so, and then in the code, that's the password. Password is the line match, everything after that. Which, if we go back to our regex test, we've got that. It's going to get everything past that. All right, what is utils.md5? UI utils. Let's see, find IAM UI. Oh, no, utils. Utils. All right. So utils.lua. Okay, so this one doesn't actually have the MD5 function in it. That's where I was. So this uses require OUIA utils utils. All right. Okay, so it's utils.so. All right, let's grab that. Nice, that's an elf file. Okay, okay. Save response to a file. Utils.so. Yeah, looks like that's full on binary. MD5 sum. Okay. Hmm. Crypto.js, MD5. Requires crypto.js, crypto MD5, blah 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 blah, toString. It gives me the token. Hmm. Yeah, I don't know. Anyway, what was there was one other fun thing that I wanted to show you guys. Where was that? What was it? Oh yeah. The unauthenticated APIs. So in one of these files, if I can find it, I had it written in my juice. There we go. So these are no-auth methods through the OUI HTTPD service. And this is listed through UCI, which is the configuration tool for OpenWRT routers. And what this is, if I go and I look at, I think it's under here, no auth. If no auth methods, let's see. Right, so this is where it's checking to see if the method is a no authentication method. So it goes and it makes a UCI cursor, and it gets all the items under OUI HTTPD no auth methods, which is what I just showed you. And if that is a method listed under there, then it doesn't actually request authentication. And then there are a couple methods under there. There's the getlang, load locales, check initialized, and init. And all of these are RPC methods that exist under this UI object. And those are called by this RPC call method, which is over here. It's kind of like a generic RPC method. So all these others over here, so like the challenge, login, logout, and alive, these are all for maintaining and managing a session. And then this one is kind of like a generic RPC forwarder or forward call where you make a request to this with your parameters, your object and method, and then it sends all of that to this this backend RPC function to validate whether or not you can do that. And that would be for doing things like changing settings on the router and stuff like that through the web panel or web console. But this method, the call one, is interesting because it's sort of a generic method. If we look at this, let's see. If we look at this, we can kind of figure out what it's actually trying to do with this method. So first off, it checks to see if you've got less than 3 parameters. If you do, it throws an error. And then when it does those parameters is the first one it assigns to the SID, second is the object, third is the method, and the fourth is the args. It goes and does a couple more checks. And then ultimately, we get down here to the is no auth, and that's where it's checking to see if your object and your method are of those no authentication RPC methods. And if they are, if it is a no auth method, it'll just straight up bypass and then call the RPC method. If it's not a no auth method, it'll call RPC access to check and see whether or not your user, your SID, has access to that actual RPC method. So one of the things that I wanted to do is dig into those no auth methods to see if there's anything broken about them, or maybe interesting that you can kind of exploit or use to maybe get yourself a valid SID or call other RPC methods. And I ran into a challenge where that CGI bin, or the RPC method, or whatever the code that's actually getting called by the RPC method, is compiled LUA and not actual, like, just raw LUA. So I had to find a way to decompile that a little bit and get something useful out of it. And let me see if I can show you where I found that at. So it goes and it does our RPC call. So if we come into our RPC LUA file, we look for RPC call. Where is it? Where is it? There it is, RPC call. So what it does is it goes and it calls scripts that are under this directory. So it'll go and it'll find the script based off the name of the object. and then it loads that. And if you can access that, then it'll run it with GLC call. I'm sorry, if you can't access that, if you don't have access to it, it'll run it with GLC call. And then regardless, it goes through and it runs the actual scripts that are in this directory. So if we take a look at what's in this directory. Oops, not that one. We can see there's a handful of interesting stuff. And then we also notice the UI item. This is the one that's responsible for those no auth methods. Or not. All right. So cool. I like it when the stream just breaks. Let's see. Let's see where we're at. All right, caught back up. Okay, cool. What did we miss? Okie dokie. Anyway, let's see. Let me get this over here so I can monitor shit. Okay, when it breaks again, I can restart it. Okay, so we're over in Linux now, and the reason why I wanted to do this is I wanted to show you this this LUAC file. So if we go into our tempfs, we've got the user lib OUI HTTPD, and we've got all those files on the file system that were under that RPC directory. And so these are the available RPC items that you can call with that generic RPC call function. So let's go ahead and let's open a terminal to this directory. Okay, cd desktop. All right, tempfs, user lib OUI HTTP. All right, so we'll do file, and we'll list everything in here, and we'll take a look at the file types. So this file just runs and looks at the magic bytes at the beginning of each file, and will tell you like what that file is, what type of file it is. So in this case, the one that we're curious about is this UI file right here, and we can see that it's LUA bytecode, which means that it's compiled LUA, which makes it a little bit trickier for us to actually like review. We can't just kind of look at it. We can run strings against it. Oh, I'm not in the right. Oh, I am. Okay. Yeah, strings.ui. And so we can see like all the strings that are in here, but it doesn't give us the actual like LUA code to kind of review. So one of the things that you can do is there's a tool called Ludeck. And I went ahead and let's see, Ludeck. Or is it me? Let me just pull this open. I got it somewhere. Here it is. All right, Ludeck 5.1 or Ludeck 51. So this is the tool that's built specifically for OpenWRT, because apparently Lua compiled for OpenWRT is specific to OpenWRT. So I've gone ahead and I've set this up, and what we can do is we can run Ludeck, pass it the file, and then give it a an output file. Oops. Let's see, desktop. In UI.lua. All right, then what we can do is we can go and take a look at that. Mango Lua UI.lua. And we'll open that with gvim. Take a look at it. So you can see it was decomiled. It's not going to look exactly like raw LUA code, but now we actually get an idea of what the hell's going on in here. We can see our function names. We've got our init function. Let's see what else. What else do we got? Our check initialized function, our load locales, our get menu list, set lang, all these other functions that are available to that RPC endpoint. So this is useful. Specifically, we're interested in like the get lang and the load locales functions, because those are the non-authenticated ones. You don't need authentication to use those apparently. But specifically the load locales function is interesting because this one actually accepts your parameters, accepts user parameters. So if we manipulate those user parameters, we can maybe make this thing do some fun stuff, and potentially have access to some files on the file system or something. That's potentially for another stream, something to be looked at in the future. But I wanted to show this off because I think this is interesting, being able to take a compiled LUA file and spit out the decompiled code into something a little bit more readable and actually analyzable. But that's I think that's about it. I think we've been going for long enough. But I think I'll stop it here and then pick this up later for some more analysis. Okie dokie. Bye.